That's the Doobie Brothers. We talked about this. Make the magic happen. Come on. Nah, it's me. Nobody wants to look at me. Oh, okay. I'll go up because there's a couple of things I want to say first. It's always a little bit tricky to get this just right when I'm doing this weird thing with the two screens. So let's see if I can do this. Now, you see there's a bug. Look at this. There's a bug in, there we go. There's a bug in PowerPoint that makes it do that stuff. It's an actual bug. It's a documented bug. So what we're going to see here today is a ridiculously rapid introduction to rapid software testing. That's what we're going to do today. I'd like to thank Armando for that very generous introduction. Whew, there we go. Okay. So I'm Michael Bolton. I'm not that guy. I'm not that guy either. And I'm no relation to that. If you want this, the notes for this presentation, they're going to go up shortly after this talk, up on my website, which is www.developsense.com. This talk and all the stuff that I do comes with lifetime free technical support. So if you have any questions, follow up, anything you want to do to follow up on this little experience that we're about to go through, I'm happy to provide that. And that comes for free. They do like coaching on Skype and that sort of stuff. We can talk about whatever you like, especially afterwards in the networking, because you'll have a lot of questions, trust me. Some thank yous are in order to Jeff Perkins and to Gina, who, among the rest of the QASymphony team, have taken care of us all, I think, really wonderfully. And I got a special one for the AV people, because the AV people never get thanked. And so I'd like to thank them for this. Some colleagues who helped me out with this, and then I'd also like to thank you because, as I say, this may get a little rough. So first thing we got to figure out is what we're here for. So let's see if we can do that. Click there. Up comes the bug. You're supposed to be able to defeat this, but you can't. Here we go. What I'd like you to do...
In this competitive environment, we have to be...
What I'd like you to do, by the way, is I would like you for the next couple of minutes to think like a tester. To think about things that could go wrong, to think about problems that could happen. Here we go.
Competitive, and all we're doing here is eliminating miles that the driver could potentially drive and helping make that driver more efficient when they do their job.
It's an octocopter. It's designed with enough redundancies to stay in the air. So if one prop should go out, it can still fly. If two goes out, it can still at least land. It's talking to the truck via RF, and we have 4G. Dual communications, 8 props, 8 motors, multiple systems inside there, all designed to keep it in the air. The truck is its own beacon. It's broadcasting its position. The bird is broadcasting its position. So the two through the cloud are talking to each other. So we put a battery in there that can do the line of sight, and then when it redocks with the truck, can charge very quickly off the giant battery in the electric truck. So it's just designed to hop all day, short hops.
The FAA last year released Part 107, which basically allows for visual line of sight operation below 400 feet with a drone upwards to 55 pounds that can fly upwards to 100 miles per hour. What will happen next as the technology emerges is a beyond visual line opportunity, as well as the opportunity to fly over people.
Ultimately, we wanted to work on any vehicle. When the regulations and the technology gets to the place that we need it to be able to do it and be safe for everyone, then we would really want it on possibly any vehicle.
That drone is the same color as the truck, is the same color as the uniform, and so it's trusted. If somebody tried to hack it, the driver at least would know about it. Yeah. If we were sending it beyond line of sight 30 miles, right, and somebody hacks it, the odds of knowing what happened are very rare. But here we've got somebody basically watching it. In the end, the whole thing is software, right? And the key to keeping it safe is to keep them talking constantly all together. Our main server is watching everything. Worst case, if we lost 4G, then the truck is broadcasting an RF signal. It can grab that and return to truck. The driver can take control at any time. It runs fully autonomously. So to have an autonomous route that all of a sudden the driver could take and say either recall it with one button push or navigate it back in case the driver saw it was having trouble somewhere. This is the first live test, right? So now that we've successfully made it through this, we'll just continue to develop and refine.
Think about this. I mean, isn't this the coolest thing? Think about what it would be like to test this stuff. Look at all the different technologies that are involved with this. And here is the thing that you didn't think about as a risk. Guaranteed, unless you've seen this before. Ready?
Well, sort of. What happened there with the...
Yeah, I don't know. We tried to do, for the photographers, so we tried to do a kind of an augmented, quick, non-traditional delivery, and something went wrong. We probably shouldn't have tried something weird like that with everybody watching.
Oh, dear. I love that. I just love looking at that. Love seeing that. So now, of course, imagine that you are somebody working for UPS, or what's it called, Workhorse, or whatever the guy's company name is. What's happening? Well, we're making a product. We need you to start testing it right now. What do? Well, it's obvious what you do, right? You prepare test cases, and then you execute test cases, right? I'm getting people saying no. Paul, why are you saying no? Man, come on. I know why you're saying no. Okay, I'll read your mind. I'll read your mind, because you know it's different. You read the specification, see? And then you identify specific items to be checked, and then you prepare test cases, and then you execute test cases, right? That's exactly how it works, right, Paul? I like your answer. It's the way a lot of people think it works. We know as testers that's not the way it really works. The way it really works is like this. You read the spec. Oh my God, there is no spec. Oh wait, there is a spec. I found it. I'll just read it. Oh my God, it's old and it's confusing and it's wrong. Well, maybe I should ask somebody. That's what we'll do. We'll ask somebody. We'll talk to somebody about it. And oh my God, nobody seems to know how this thing is supposed to work. So, is there anything that I can test? And the answer is yes, of course, there's always something you can test. And this is one of the things that worries me a little bit about because what I've seen happening, I've seen testing reduced to a whole bunch of stuff about like running test cases on a running product. And for lots of reasons, I'm going to talk about why I don't think that's terribly helpful or a terribly empowering way to think about testing. You can test the product, absolutely, but maybe you don't have a product. Maybe you've just got a mock-up of the product. You can test a document describing the product. You can test a diagram that models the product, that describes the product in some way. You can test a product like this product. You can test somebody's ideas about the product, because testing is not simply running a product and seeing if it produces an expected result. It's not like that at all. Testing is a process of evaluating a product by learning about it through exploration and experimentation. That's what testing is about to me. There have been a whole bunch of questions raised about testing that are kind of interesting. Like this one, for instance. Does this test case pass or fail? Not an interesting question. Not an interesting question. It's only interesting with respect to a problem. If the test represents a problem, if the test produces a problem, a test case can fail, and it's still not a problem. Or a test case can pass, and there can still be all kinds of problems with the product. How many test cases do we have? That's a silly question to ask. Test cases are like briefcases, right? You wouldn't evaluate the quality of your company's business by counting the number of briefcases that come in the door every morning. Or you wouldn't evaluate the value of a train shipment by counting the number of boxcars on it. You don't know if they're empty or not. You don't know what they contain. So how many test cases is not an interesting question. Test cases aren't commensurate in size. They're not things. They're not widgets. What's our pass-fail ratio? That's even dumber. That's a dumb question, I think. What's our pass-fail ratio? Who cares about what the ratio is? I want to know what's going on with those tests that are reporting some kind of failure. How long do you need to test? Another completely uninteresting question. Why? Because they'll tell you right away. They'll tell you how long you got. It's not a question of how long I need. I have to do the fastest, most efficient testing that I can do. Because ultimately, there are really only two questions that are really super interesting, and a whole bunch of the other ones devolve from that. For testers, number one, is there a problem here? I don't care whether a test case passes or fails, unless it's relative to some problem that some person might have. Some kind of undesirable situation, some kind of a thing that, or a problem that a person doesn't want. The other fundamental question of testing is, are we all okay with this? Right? Test case passes, okay, that's great, but are we okay with this product? We're going to have to cut our schedule by 2 weeks because the developers were late. Okay, is everybody okay with this? There's a risk gap. There's a gap between what we know right now and what we need to know. And we don't know how we're going to close that risk gap in the time we've got available. Is everybody okay with that? If we start framing our testing in terms of those questions, then I think we start to be more productive as testers. People only ask you about that other stuff when you're not answering these questions, right? Those other things are stand-ins for these two critically important questions, and therefore, they don't trust you if you're not answering these questions. And so they'll put on the headdress and the grass skirt, and they'll dance around you, trying to get some kind of a weird substitute answer for what they really want to know. Because what the managers really want to know, I can tell you this because I've been a program manager. I was a program manager for what was at the time the best-selling piece of software in the world. It's so weird to think about that because I don't remember it as being anything special. I was just going into work. It's like the Beatles. The Beatles never knew what it was like to be the Beatles, right? Because they were the Beatles. So they didn't know anything different, and then the rest of us don't know what it's like to be the Beatles because we weren't the Beatles. Here's what program managers want to know. Project managers want to know. Business, this is what the business wants to know. Very straightforward question. Are there problems that threaten the on-time, successful completion of the project? That is our job as testers. And it's a great job to have because it requires us to be skilled investigators. Which brings us to the premises of rapid software testing. Software projects and products are a relationship between people, fundamentally. And people are funny. People are strange. They've got ambitions, and they've got desires, and they've got needs. And our software gets in between groups of people who have something that needs to get done and getting it done. Our software helps to facilitate that. Our software takes the place in society where people used to occupy. And so instead of checking to make sure whether the machinery works right, well, that's an important task, that's an important part of it, but I think our value as testers, since products can be checked, machinery can be checked by machinery, our job as testers is twofold. It's to figure out how to program that machinery and how to make the best use of it, to check the software, but also it's our job as testers to do as Harry Collins says. He's a name that's come up a couple of times. Keith mentioned him this morning. What Harry Collins says that we have to do as testers is we have to make a complex social judgment about whether people are going to be happy enough with the differences between what the product does and what a person would do in that situation. That's a key aspect of what testing is all about. And I worry a lot that that's getting lost. That's getting lost in obsessions with process models, in obsessions with tools, in obsessions with documentation and artifacts, in obsessions with test cases. The test cases do not answer that question. All right, so that's point one. Every project occurs under conditions of uncertainty and time pressure. Why? Because of people's ambitions and because of economics. Our job is to try to get software out as quickly as possible and as necessary to fulfill the purposes that people have for it, because otherwise we're going to end up working for our competitors or not working at all. Next thing is, because we're always developing something new, we're always developing something that is to some degree novel, never been done before, right? The world has survived all this time without our software. Why are we in such a rush? But because we're developing something new, we can expect people to be, to some degree, incompetent, And because they're people, we can expect them to be careless, and we can expect them not to know exactly about how to build the thing we're building because we've never done anything exactly like it before. If the old stuff worked, we'd just press the copy command, or we'd slide a folder over onto another folder, or we'd put something up onto the web server, and everything would be great. So, that puts rapid software testing in a social context, and it identifies some practical limitations about it. The problem is that software projects and products are fraught with risk, and it's our job to investigate risk. Now, what we do in rapid software testing is we don't sort of wave our hands at stuff like this. We try to think deeply about it. We try to think deeply about it. So here's a risk model for you. Somebody was talking about risk this morning. Here's the deal. Some person or persons, somebody, as an individual or a group, or people who aren't even directly related to the project necessarily, will experience a problem. That is to say, they'll get a bad feeling about something, and there will be something that will trigger those bad feelings. The problem will take the form of loss or harm or annoyance or diminished value or dissatisfaction or impatience. That's how that problem will be noticed with respect to something we want. And we'll talk about quality criteria in a minute. That can be detected by an oracle, a means of recognizing a problem, in some set of conditions because of a vulnerability in the system. Okay, that's what risk is all about. If you want to sum it up a little bit quicker, bad thing might happen. And it's our job as testers to explore the bad things that might happen and to conjecture over other bad things that might happen. People who work on the project, who are building the project, they got to put that aside. Otherwise, the cognitive load of having to deal with all the possible problems, they'd have a really hard time with that. It's hard to flip between the builder's mindset and the tester's mindset. Microphone just went out. Now it's back. Hooray. That's not a hint, is it? Problem, bad thing might happen. Okay, another premise of rapid software testing. This is really important. A test is an activity. It's a performance. It's something we do. A test is what you think and what you do. A test is not an artifact. That thing that you got written down on the test, that's music, like dots and lines printed on a page of paper are music. That's not music. It's musical notation. It's something that would guide somebody who's going to perform music. Sometimes I do this demo. I play a MIDI recording of a piece of Irish traditional music, and then I play an Irish traditional band playing it. And the difference is, of course, night and day. One thing is very mechanical, and it doesn't invoke feeling, and it doesn't invoke dynamics, and it doesn't identify all the things that real people do, and real people play real music. Testing's job is to discover the status of the product and threats to its value so that our clients can make informed decisions about it. That's why we test. Our job as testers is to commit to performing the most credible, cost-effective testing we can, and if we can't, if we're constrained in any way, it's our job to report to our clients about those constraints. We'll come back to that point too. Another ethical premise is that we will not knowingly mislead our clients or ourselves or our colleagues. And that means, in rapid testing, it means that we don't give test case metrics to management, because management doesn't care about them, and they will be used against us in various different kinds of ways. When a manager asks me for pass-fail ratios, it's like the drunk guy asking for the keys. You know, it's like, nope, you're not driving home. If you even want that, you're in no shape to drive. No, stop asking. Now, what do we give them instead? We'll get to that too. Testers do accept responsibility for the quality of our work, but we do not accept responsibility for the quality of the product. How many people here have a title, quality assurance? Okay. Can I pick on you? It's like the comedian at the club, you know. They don't ask permission, they just go straight for you. So you have an option if you want. Okay, you got a job called quality assurance. Do you control the schedule for the project? That is to say, if you want to ship early, you know, can you say, okay, what about the budget? Scope of the product? No. Do you have hiring and firing authority over the developers? No, interestingly, okay. Do you have, I know what you might have. You have authority over contractual obligations to clients, right? You have that, right? No, okay. So how exactly do you assure quality? You don't. None of us assures quality unless we are the CEOs of our organization. We don't assure the quality of the product. We can assure the quality of our own work. And it requires us to tell stories about it. So, and we'll talk about that too. So these are the premises of rapid software testing. There's a practical focus, there's a duty of care, and there's a scope of responsibility, which is a lot more limited than people are prepared to admit much of the time. So, rapid software testing, to tell you about what it is a mindset and it's a skill set of testing. And it's focused on how to do the fastest, least expensive testing we can possibly do while still remaining entirely credible and accountable and completely fulfilling the mission of testing. And that means getting rid of waste, means getting rid of paperwork and documentation to the greatest degree possible. And sometimes people ask, what if we're in a regulated environment? And my response to that is, hey, that's part of the deal. But read the regulations. Read the regulations. How many people are working in a regulated environment? Keep your hands up if and only if you have read the pertinent regulations, the ones that actually apply, all of them. A lot of hands go down. Okay, so that means that in regulated environments, a lot of us are working on rumor and folklore as to what the regulations actually are. Read the regulations. You'll find out really quickly all that crap that people are trying to sell you in the 2000s about Sarbanes-Oxley and how it means that we have to have certain kinds of documentation for our testing. Sarbanes-Oxley says nothing about software testing, absolutely nothing. All that crap was a hoax, total hoax. In order to accomplish this stuff, we've got to focus ourselves on the individual tester, the skill set and mindset of the individual tester, and that means we have to focus on how we learn about stuff when we're under pressure to learn stuff. That's what we're focused on. How about, people will ask us, what about management? A quick answer for that is we focus on activities, not artifacts. What about metrics? We don't count test cases. We might account for how we spend time. That could be pretty useful information, as we shall shortly see. What about automation? Hey, we use tools, but we don't say that automation does the testing. We don't talk about automated testing in the rapid testing namespace. What we talk about is we talk about automated checking, which we'll also get to in a bit, and we also talk about tool-assisted testing. Tools extend and amplify, enhance our testing, but they don't do the testing. If we keep talking about automated testing, people will continue to believe that testing can be automated. Programmers don't talk about automated programming, do they? They talk about compiling, but they don't talk about automated programming in the same way we can talk about automated checking and not talk about automated testing. Reporting. Testers have to learn to report and explain. Documentation. Concise. That's all I'm going to say about that. Speech, precise. Now, Keith was talking this morning a little bit about precision in speech, and it's something that's really super important to us. And the reason for that is, as Keith put it, if we don't be specific about what we're talking about, we are going to talk past each other. Guaranteed. Guaranteed. The chance of misleading somebody rises dramatically when you're not too prepared to speak precisely. And the way I've been talking about it lately, it's, I feel it's like a Louis C.K. bit almost, where the software has problems, and I need the things, and we got the bad things in the software. No doctor talks like that. Doctors speak very precisely because the difference between a virus, a viral infection, and bacterial infection is important. It's significant. It's really significant. Because if you don't make that distinction, you talk about, you basically apply the wrong solution to the problem. And then we end up with stuff like antibiotic-resistant bacteria. So it's important for us, I believe, if we want to be treated like professionals, to talk like professionals, to speak like professionals, to be careful of what we say and how we say it. So here's a big long list of, two big long lists of things which are designed to impress and intimidate management when they try to hassle us because they might suspect that we're not entirely on our game. In rapid testing, First of all, we frame our work based on a historical kind of perspective. People like Jerry Weinberg, Herbert Simon, Harry Collins, who provoke us to speak clearly about what we're doing and how we're doing it. So we talk about context. We listen and we respond to the world that's around us. We talk about our role. We take responsibility for our work, and we also reject responsibility for things over which we have no control over or authority. We pay attention to our mission and our motivation. We think in terms about ethics and integrity. We don't want to deceive people, and we don't want to waste their time or their money. We need diversity in this business. And one of the nice things about living in Toronto, and one of the nice things I see around here, I see all kinds of different genders, obviously, ethnicities, cultural backgrounds, educational backgrounds. Testing benefits from that diversity. We've got to diversify our teams and our tactics if we're going to test successfully. Relationships. We are working with different people all the time, and we have to manage those. Skills. We have to build our skills and develop them. We have to treat essentially the game of testing like any professional sport, where we're learning something from every game. We're focused on learning something from every game, and where we deliberately practice our craft. We talk about heuristics. A heuristic is a fallible method for solving a problem or making a decision, and everything in testing, everything in engineering is heuristics. All of our methods can fail when they're applied in the wrong way or when they're applied in the wrong context. Exploration. Testing is fundamentally an exploratory activity. It's got to be. Why bother going over ground that we've gone over before? If we're not learning something from every new test, why do it? Why run it? Product risk. We talked about product risk. We talk about tests. We don't talk about test cases. We talk about actual tests, performances, not artifacts. And we talk about models. In order to do this, we need models not only of the product, not only of the project, but we also need models of our testing. So here we go. Fasten your seatbelts. I'm going to whip through the heuristic test strategy model. Here we go. We break the product down into its elements, its structure. Now watch this, by the way. I'm going to do it without looking. I might, where the slide goes, I might need to navigate, but I'm going to do it without looking. This screen is not this screen. So, all right. We break the product down into its elements, its structure, the bits and pieces, functions, what it does, data, what gets processed by it, interfaces, how stuff gets into it and out of it, operations, how people actually use it when the rubber meets the road, platform, how people, the things that depend on the product and what depends on it, time, how the time interacts with the product and how the product interacts with it. Then what's next over there? Test techniques? No. Project environment, okay. We think about mission, information, developer relations, test team, equipment and tools, schedule, test item, and deliverables, all the things that are context factors in the project. Then it's test techniques, right? Test techniques, function testing, domain testing, stress testing, flow testing, scenario testing, claims testing, user testing, risk-based testing, automated checking. Then we also have to think about quality criteria. Quality criteria like capability, reliability, usability, security, scalability, performance, installability, compatibility, charisma, I missed charisma, and supportability, testability, maintainability, portability, and localizability. Now, you want to find problems in the product, we got to find inconsistencies, the principles that are listed there. Inconsistencies between, well, if it's consistent with patterns of familiar problems, it's probably a problem here too. But otherwise, if the product is inconsistent with explainability, with the world, with history, image, claims, comparable products, user desires, with itself, the product, with purpose, with standards or statutes, we suspect that there's a problem here. And our other ways of identifying problems in the product are our feelings, other people, and maybe their references, artifacts, tools, specifications, comparable products. Okay. Now, you think any manager who comes along and says, listen, are you on top of it? You think if you've got that committed to memory, if you got that committed to memory, do you think the amateurs are going to hassle you? Right? It's important now. You don't have to use our model. You can use your model, but it's important for you to have your model. Every tester must invent testing for his or herself. So that puts a lot of onus on you, and I hope you pick it up. Testing is also telling stories. And we talk about a braid of a three-part story, each story weaving around each other. We got to tell a story about the product, what it is, what it does, how it works, how it doesn't work, how it might not work, how it might fail in ways that matter to our clients. And most testers are kind of, not too bad at that. Not too bad at that. What testers aren't always so good at is they're not that great at talking about how they tested, how we configured, operated, observed, and evaluated the product, what oracles we applied in order to recognize problems. If testers aren't that great at that, we're not very good at talking about coverage, how we covered the product with testing, what elements of the product got covered, the models that we used when we were covering the product. Now, to the degree that testers aren't very good at that, it seems to me we're mostly downright miserable at describing important testing that has not yet been done. That's why we need to have good models of the product so we can identify what has and has not been covered. Third level story, which testers are terrible at. Testers are terrible at telling the story of the quality of their testing, why the testing they did was the most fabulous testing we could have done, given the time and the resources we had, or if there were problems, what the problems were. What made testing harder or slower? What made testing more difficult? What got in our way? What slowed things down? Now, we're not very good at, we're great at telling it to each other, right? We gripe at each other all the time, but we don't get that information up to management. And the reason that it's important for us to tell about what we haven't covered and why we haven't covered it is that stuff is where the risk lives. Risk lives in the parts of the project that we haven't covered. So we also need to talk about how testable the product is, what we need, what we recommend in order to make the testing more fabulous than it already is. So the first level story is a story about bugs, basically. The second level story is a story about coverage, and it's about oracles. The third level story is about issues, things that got in our way or slowed things down. We've got to get good at telling that story. Those who can do that well, they can develop their skills in testing and their skills in reporting can account for their test coverage. But if you don't focus on that skills, what you're going to focus on is ass coverage. Artifacts. Whole bunch of cargo cult-like mythology and folklore, a whole lot of weird ways of describing and measuring testing. We don't want to do that. Now, a lot of people believe that to test well means to run a great big fat test case rerunning machine. Like this. I rerun my old test to make sure that nothing is broken. So you do a few tests, you find a few bugs, and then you use automation to find those bugs, and make sure those bugs never come back again, and everything's okay. But that can only be good testing if you have perfect oracles and if you cover everything so that all conceivable bugs are being detected. What is a more accurate story, I think, if we tour the product a bit, we find some obvious bugs, and we hope the bugs that we miss aren't bad ones. The trouble is, when we don't add variation to our testing, when we don't make our testing an exploratory activity and rather a confirmatory activity, we're going to miss lots of bugs. If we over-formalize our testing, we're going to miss lots of bugs. Because, I don't know if you've noticed, but bugs don't follow standards. Bugs don't follow formal processes. So we've got to deformalize in order to find bugs. Then we get stuff like this, right? Follow steps can be performed simultaneously and in any order as required. I think this is from the ISO 29119 standards. It's complete BS. It's, I'm serious about it. It was set up by a bunch of consultants in order to market their services. What they do is they create a problem, and then they solve the problem for you and charge you a lot of money for it. It's rent-seeking is what it is. And I urge you to join the debate on this, because this is not testing. This is obsessive demonstration at best. That's what this is about. See, testing's like that. Testing's like that. Testing happens in a complicated, confusing space, and we got to learn to be comfortable with that. Scripted testing's like that. That's what the Army looks like in scripted testing. Now, I used to say exploratory testing here. I don't anymore. We don't talk about exploratory testing anymore. We're kind of deprecating the term. Why? For the same reason that it's like talking about vegetarian cauliflower or, carbon-based human beings. We talk about the testing role. There are 3 roles that we talk about in rapid software testing. We talk about responsible testers, people like you folks. Or maybe you're a test leader, a test manager, where your job is to cultivate and support those folks. Your job as a test manager, it seems to me, is mostly to remove obstacles for your people, not to monitor them, not to mandate them to do stuff. Let them free. Give them freedom and responsibility. Responsibility, sure, but don't tie their hands up. Don't tie their hands up and then make them go into battle that way. Of course, responsible testers also need to cultivate and support what we call supporting testers, developers, business analysts, anybody who can help us testing. It's our job socially to connect with those people. All of the people who are actually doing testing are responding to clients and to context. The supporting testers don't do that directly necessarily. And test leads and test managers, responsible testers, supporting testers, use heuristics and tools in order to get the work of testing done. These people in particular, the responsible testers, need freedom, and they need wisdom, and they need responsibility. So if your job is a test manager, a test lead, your job is to foster that, to foster wisdom in your testers, to help keep them focused on the mission. Here's another thing we talk about in rapid software testing. We call this checking, not testing. Checking, either by mechanical means, which is sort of kind of okay, or by a human tester who's been following a script. We're operating a product algorithmically to check specific facts about it. Think fact checking or spell checking. But a spell check document is not necessarily a compelling document or an interesting document or a worthwhile document. It just has some spelling corrections, and they may not be actual corrections, as those of us who use autocorrect know, right? I Kiev my wife, and I hope she Kievs me too. That's part of testing. That's part of testing. But it's a part that could be performed by a machine, which has the advantage of being quick and precise, or by a sufficiently disengaged human being. Checking is the part of testing that can be done mechanically, that can be operated mechanically. But testing is so much more than that. Testing is evaluating a product by learning about it through exploration and experimentation. And that includes, to some degree, questioning, studying, modeling, generating ideas, abandoning ideas when we have too many of them, overproducing ideas, which is how we have to abandon them, but then retrieving ideas, cultivating ideas, collaboration, conjecture. Those are all testing activities, and none of those things can be automated. None of those things can be automated. So don't worry, folks. Testing is not going away. The role of the tester, though, has to shift away from a mere human checker into somebody who takes authentic responsibility for this stuff. Creating the conditions necessary to do it, too, so that our clients can make informed decisions about risk, and also building the inclination, the desire, the motivation, the credibility, the reputation for being able to do that stuff well. Oh, and by the way, if we're actually doing good work, that will help to make the product better. But we don't make the product better. We don't assure quality. They say automate all the testing. That's what they say. They say automate all the testing. Can we automate all the testing? Well, we could. We could. All we would have to do is automate all the evaluation and learning, exploration, experimentation, and modeling, and studying the specs and observation of the product, and inference drawing and questioning, risk assessment, task prioritization, coverage analysis, pattern recognition, decision-making, design of the test lab, preparation of the test lab, sense-making, test code development, tool selection, recruiting of helpers, making test notes, preparing simulations, interacting with developers, bug advocacy, triage, relationship building, product configuration, application of oracles, designing visualization, spontaneous, playful interaction with the product, discovery of new information, preparation of reports for management, recording of problems, investigation of problems, working out puzzling situations, building the test team, and analyzing competitors, resolving conflicting information, and benchmarking, and there's a whole bunch of other stuff that we have to do too. They might have meant automate all the checking, which would not be so bad, but then we have to make decisions about what checking we're going to automate and what we're not, what's worth automating and what isn't. And I see a whole ton of stuff that's getting automated, has no business being automated, no purpose testing it at all. How do you make it faster to do that? Don't do it. Don't do stuff that doesn't help. Or they might mean use tools. That's okay. That's really important. All testers use tools. And the more skillful we are at using our tools, the better off we will be. But let's not put limitations on the kinds of tools we use. Now, very quickly, here is the universal development cycle. Universal development cycle. Isn't this great? We've discovered the universal development cycle. Here it is. We discover something we're building. We build some of it, and then we build it virtuously. And then we study what we built. We did this work in order to try to debug Agile testing and the way people talk about testing in Agile context. Here's a big hint. Testing is testing. Agile is context. How about that? A credit to Scott Barber for coming up with that. So here's the way testing used to be done. We discover something worth building in a long loop, and then there's a few short panicky ones after that. Then we build some of it, that is to say almost all of it. We study what we built, we find out, oh my God, there's all these bugs. And then we go through a series of very short, very rapid loops before we release it. See, the thing is, build it virtuously in a traditional development cycle is get it right the first time. And so it takes a long time to build that first version. Agile changes this, I think, in ways that are positive. Lots and lots of short loops. And when we build some of it, we build a little tiny bit of it, because that makes it easier to do the next thing, the virtuous part, which is to build it with change in mind. Build it realizing that we're going to make mistakes. So we study what we built. Now, if we don't make too many big changes too quickly, we can study what we built quickly and easily. But if we make too many big changes all at once, then we know the risk of problems is higher, and the effort required to find those problems is higher too. So we build it with change in mind. Testing is working with development. So this is the sort of a framework for our take on how to do testing in Agile context, but actually it works for anything. It just mostly depends on the loop and on your concept of virtue. I want to build with change in mind all the time. So we discover something worth building. As we do so, we develop the design. And as we develop the design, we do testing that helps to develop the vision for the product, what the product is going to look like. Testers participate in that. And if you don't, time to invite yourself in. Well, or at least if you can't invite yourself in, maybe you can't do that very well or very easily. The least you can do is talk about how expensive it is when you don't. Right? Make that part of your level 3 testing story. Couldn't get in on the meetings, didn't know what was coming, makes testing harder or slower. We build some of it. We develop the design so we can build some of it. And as we build some of it, well, we get mostly into builder-style checking here, or builder-style testing, output checking and review, that helps us to avoid simple coding errors and helps to put a little bit of a seatbelt or an airbag around regressions. That's what the unit checks are all about, the ones that the developers might not be building. And if they're not, we talk about the cost of that, what it costs the business, the risk it costs the business. As we do that, we build it cleanly and simply so we can build with change in mind. And here in the bottom left-hand corner, we get into the stuff that testers collaborate with developers on. In really close collaboration. That's what we do. We work with developers to foster a testable environment. And then, up in the top left corner, over in this is where testers really live. This is where we do deep testing for hidden or rare or subtle problems. This is where we experiment imaginatively and suspiciously. Words that we got from Jerry Weinberg. A suspicious nature and a lively imagination. Doesn't that sound like a lot more fun than going in and running test cases every day? All right. What does rapid software have to say? What does rapid software testing have to say about standards? ISO 29119. Other standards like, what is it, 2009, whatever they do. Here's what we have to say about it. ISO 2000, ISO 9001-2000. There we go. That's an actual picture that I took in India. This is indeed an ISO 9001-2000 certified company right there. All right. Want to leave you with some actual practical stuff. And this is only the beginning of the conversation that we're all going to have, I hope, when we get the panel out of the way and we go over here and start talking about testing again. Resist test case and scripts. Focus on test activities. Focus on telling the testing story. Test cases are widgets. They're nothing. They're not important. Certain conditions to examine are important. Specify those by all means. But let's not get obsessed with the test cases. And I know what's going to happen. I'm going to go back there and people are going to talk to me about test cases again. And I'm going to get all disappointed and upset, so don't let that happen. Let risk guide your activities. Test in sessions, bursts of uninterrupted testing work, and then review that work and report on it. Paul down here can tell you about how his life changed when he discovered that this is a real, authentic way to do testing, because it brings the project the goods. It tells him about problems and it doesn't obsess over the trappings and this unnecessary stuff. Avoid premature formalization. Avoid excessive formalization. Testing doesn't have to be too formal. And when it does have to be very formal, there are good ways of doing that still honor this idea of eliminating waste. And we can talk about those too. Use recording tools, by all means. Use them like an airplane's black box, right? When nobody looks at your testing unless something goes terribly, terribly wrong. But it's kind of handy to have. Sometimes we get lost when we're testing. We lose track of what we did. And it's a Q-test, the obligatory pitch for the sponsor's product here. A Q-test Explorer is a kind of recording tool that I absolutely love. It doesn't record tests. It's not going to repeat the test for you. It's going to show you what you did in a way that reduces the burden of note-taking and allows you to illustrate your note-taking. Great idea for a product. Emphasize exploratory scenario testing. That's where the bugs live, the way people actually use the product. That's where the bugs live. But another kind of testing that we can do, technically, is to probe the product, to visualize results, to aggregate results, to drive stuff through. So give testers lots of tools and lots of support for learning about them, but don't let tools overwhelm the discussion. When we want to talk about tools, okay, don't use them to do the testing. Tools don't do testing, you do. Don't become fixated on tools. All right? Fixate on skills if you're going to fixate on anything, not on the tools. But use them, by all means, use them for all kinds of things, not just automated checking, but also for setup configuration management, for data generation, for probing the product, for analysis, for logs files. It's so great. I almost never hear anybody, the pair of speakers up earlier, actually talking about regular expressions. Woohoo! An actual technical skill afforded by tools. Let's get into that as testers. Let's develop those skills. Develop our skills in logging and recording. But let's remember the efficient kinds of automated checking are probably going to happen closest to the actual code, not so much at the user interface. If you're going to test at the user interface, test with a real human who will notice all kinds of problems that your automated check will miss. Socially, talk about explaining testing. Practice doing that. Talk about how you're going to model your testing with your team. Diagram it out. It's a great activity. Declare your role and your commitments, what you're going to do for the product and project and what you're not going to do, and make those things clear. There are examples of that on James's blog. Don't accept responsibility for the quality of the product. We can't do that. We can't do that unless we're running the project, in which case we're not really in the testing role at that point. We're in the project management role. Get as close to your developers as possible. Hang out with them. Hang out with them socially. I almost took up smoking. And then I realized I could just drink coffee and hang out with people who were already smoking. But smokers congregate, right? From all different parts of the company. That's how you really pump the rumor mill. Also, get friendly with the receptionist, if you still have one, right? Or with admins. Those are all great people to know. But embed yourself mostly closely with the development team. Ask for testability. It's like a mantra. Ask for testability, ask for testability, ask for testability. When you are asked to measure something, try measuring this. How much time is spent on test design and execution? How much time is spent on bug investigation and reporting? Because that interrupts test design and execution, right? And then track how much time is spent on setup, getting ready to test, preparing to test, and tear down, reporting and recording, okay? When you do that, what you will very quickly notice is there may be a lot of opportunities for speeding up setup, for accelerating that, and you will also almost certainly notice that the biggest interrupter to testing productivity is bugs. right? Is bugs, right? Bug investigation reporting, that takes a lot of time out. It's not that it's unnecessary work, it's necessary. But a lot of the shallow bugs put a burden on testing. Finding a bug slows you down as a tester. So let's talk about how we can make it a less friendly environment for bugs. Finally, resist bureaucracy. Be a service to the project, not an obstacle. And that, ladies and gentlemen, is it.